All right, chapter 12 begins with looking at the inverse matrix. Now, before we do that, I want to do a quick reminder on the identity matrix. The identity matrix being, it can be any square matrix, and it's only got ones on the diagonals and zeros everywhere else. So it doesn't have to be a 3x3 matrix. It can be a 2x2 matrix, a 4x4 matrix, but it's got to be square and it's got to only have ones on the diagonal. So that's the identity matrix, and it's shown with an I. There's an interesting property about the identity matrix we haven't spoken about yet, and that is that when you multiply the identity matrix by another matrix that's pre or post multiplying, it won't change the matrix. And let's do this showing with an example. So if we have A is 3, 4, 2, 1, let's find A times I and I times A. So let's start with AI. So AI, I'm going to set it up and multiply it by I. Now, because we're multiplying A, which is a 2x2 matrix, we're assuming that the identity matrix we're talking about here is also 2x2, so the same dimensions. Otherwise, the product wouldn't be defined. So let's do this matrix multiplication. So 3 times 1 is 3, plus 4 times 0, which is 0. So it's just going to be 3 here. Then in this element, we've got 3 times 0, which is 0, and 4 times 1, which is 4. All right, so our first row seems to be the same as A. Let's see if it is for the next one. For this element here, we've got 2 times 1 is 2, 1 times 0 is 0. So 2 plus 0 is 2, and we can convince ourselves that this last one will be 1. So A times I, it's just A. It's just A again. Let's try it out with I times A. All right. So again, we're going to use this row and this column to get this element here. We're going to go 1 times 3, which is 3, then add 0 times 2, which is 0. So we just get 3 here. 1 times 4 is 4, plus 0 times 1, so just 4, and so on. 0 times 3, 1 times 2, just have 2. 0 times 4, and 1 times 1. So again, it just equals A. So this identity matrix does not change anything. And that's going to be very important for when we discuss the inverse matrix. So we've got the inverse matrix, and it's shown as A to the power of -1. So that's how we show the inverse matrix. The interesting thing about the inverse matrix, and this is how it's defined, is that A multiplied by its inverse is the same as its inverse multiplied by A, which is I. So multiplying A by its inverse will give you the identity matrix. Now, it is really important to note that not all square matrices will actually have an inverse. First, what we need to do is we need to check that the inverse actually exists. To check that it exists, we need to know what the determinant is. So we've got this formula for finding the inverse of a matrix. If A is the matrix A, B, C, D, then its inverse, A -1, we've got this fraction here, so 1 over AD minus BC multiplied by this matrix where the elements are sort of rearranged a bit. This AD minus BC, this equation is known as the determinant of A. So that's what we spoke about just before. So AD minus BC is called the determinant of A, and it's often shown as det A, shown here as well. Now what you'll notice is that if the determinant of A is 0, what happens is this fraction becomes impossible. because if the determinant of a is 0, you've got 1 over 0. You cannot have 0 as the denominator of a fraction. You can't divide a number by 0. So what this says is, for the inverse of a to exist, the determinant of a cannot be 0. It must not equal 0. Now, I know that we've got this formula for calculating a. However, I will make the case that you will pretty much never need to use it. Use your calculator instead. The only instance where knowing this can be handy is that if you've got a 2 by 2 matrix, you might be able to find out the determinant a lot quicker than having to type in your matrix, assign a variable to it, and then figure out what the determinant is in the calculator. Simply doing AD minus BC can be a lot quicker than that. But for all other purposes, use the calculator. So we've got this example here. Let's say we had A as this 3 by 3 matrix, and you typed it into your calculator, you assigned it to A. If you want to find the determinant of A, it's just det A, and it gives us that it's negative 20. So straight away you would know that because the determinant of this 3 by 3 matrix is not 0, then the inverse will exist. You can raise A to the power of negative 1 to find the inverse, and it will give it to you there. There is no quick formula that we learned in further maths, at least, that gives you the determinant for a 3 by 3 matrix. So you can only really use this AD minus BC if you have a 2 by 2. Otherwise, the calculator is your best friend here.